Okay, welcome back. In this video, we're going to go through, as you can see, some parallel lines. So looking at formulas to create parallel lines on a Cartesian plane. So let's jump right in. For the purposes of this, we've gone and actually created a Cartesian plane, and we have an example to start with for our first line right at the bottom there. So let's go ahead and work this out. In our slope-intercept formula, so y equals, so remember this one, it's y equals mx plus c. We have our formula there, y equals 2x plus 4. 2, of course, being the gradient, and plus 4, positive 4, being our y-intercept. So 2 times x to start with, 2 times negative 2, that's going to be negative 4, plus 4 is 0. 2 times negative 1, well, that's negative 2, plus 4 is 2. 2 times 0 plus 4, of course, being 4, and as you can start to see, our values here and here and here are actually going up by the same value as our gradient. Interesting that, isn't it? So 2 times 1 is 2, plus 4 is 6, and then finally 2 times 2 is 4, plus 4 is 8. So let's actually plot this line on our graph and see how we go. Let's see if we can't make these dots a little bigger. So negative 2, 0. So we've got come across to negative 2 and 0. Our y-axis is 0, so we're right there on the line. Negative 1, 2. So negative 1 and up to 2 right here. 0, 4, that's our y-intercept. 1, 6, and 2, 8. All right, so let's actually rule this line here. We're going right here. That is our line as written in this formula here. So let's go on with actually finding a parallel line to this one. And quite simply, you are always going to be given, or you will be given, several things. You'll be given this formula. So let's try y equals 2x plus 4. That's our original line. We want a parallel line for that goes through point 4, 6. Let's say 4, 6. So let's start off. Let's get rid of this. Nope, not quite all of that. Just that to make some more space. Now, very quickly, what we're going to do, I'm going to start by rewriting my slope-intercept formula. So y equals mx plus c. Now, the first thing I'm going to do is recognize that parallel lines have the same gradient. They're not going to intercept, so they have to have the exact same slope. So I'm going to drag that 2 for my gradient value down, and I'm going to put that on my next line. From here, I'm going to go up to my coordinate position, and I'm going to substitute, and I'm going to actually label my x value and my y value. This just helps me to keep track of what values represent which one. So my y I can see is 6, so 6 equals 2 times 4 plus c, because what we want this new c value. So that's what we need to find now. Now, our next step, my next step, I'm actually going to do this one here. 2 times 4. So I know my next line, 6 equals 8 plus c. Well, now I want to cancel out so that I can get c on its own. And what's the opposite to plus 8? So the little positive 8 there. What's the opposite? That's right, I'm going to take 8. What I do to this side, though, I have to do to the other side, so take 8. 6 take 8, well, that I know to be negative 2 equals c. And now I can take this value and replace this value here with my new c value to get my new parallel line formula. And if I rewrite that, it becomes y equals 2x take 2. So that right there, that's my answer. So if we do up another one of these tables, x and y, let's go -2, -1, 0, 1, 2. Y equals 2x take 2. Well, 2 times x, that's -4. Take another 2, that's -6. 2 times -1, that's -2. Take 2 more, that's -4. And as you can see, our values here are again going up by the same value as our gradient. So 2 times 0 is 2, take 2, -2. So this one is going to be 0 and this one is going to be 2. Well, let's now plot that line on our graph. So -2, -6. There is my point. -1, -4. 0, -2, and of course that is our y-intercept. 1 and 0, and then 2 and 2. Now if we get our ruler out and we rule this line again, let's just line this up. Well, there you have, we have a blue line and a green line that are actually parallel. So in the next video, we'll go through it a bit slower and we'll have step-by-step instructions for you to write out. But that right there is just initially what we need to do to find our parallel formulas, that being this one here and this one here. These two formulas represent parallel lines.